In this lesson, we are going to learn how to use nomenclature to describe multiple gestations. We're going to use twinning because it's easier to understand two rather than multiple, but this is for any pregnancy that has multiple gestations, regardless of how many babies there are. I'm going to build a framework that's going to help you as an advanced organizer remember what's what, and then go through each of the different types of twinning and the risk they carry. And that's really where you want to focus on, naming the twinning and determining risk. To start us off, we know that one egg gets fertilized by one sperm, and we call that fertilization. Every fertilization will lead to one reproductive unit. I'm using that word vaguely because it helps to understand where things are coming from later on. That is to say, there is one zygote. As baby develops, the zygote will turn into a fetus, and that's the organism itself. That organism is surrounded by a protective layer, the amniotic fluid. Not surprisingly, the amniotic fluid comes from the amnion. The outer lining of this unit is called the chorion, and the chorion's job is to go hunting for blood. That is to say, the chorion forms the placenta, which goes and harvests mom's blood. The chorion is the placenta. The amnion is the sac. And the thing growing in the middle is the zygote. We're going to use this terminology to help us determine what type of twinning there is and what risk comes from having that type of twinning. Now, mom's going to come in and get an ultrasound. Most of the time, the ultrasound is routinely done. But mom might tip you off to say, hey, something's up here, when she's too big for dates. The AFP is elevated on the quad screen. Something says we need to take a closer look. And you're going to use the ultrasound. And the ultrasound is going to show you multiple gestations. And again, we're going to use twins because it's easier to learn that way. The first thing you're going to do is look at the gender. Because if the twinning came from one fertilization, the genetic material must be the same, and therefore they must have the same gender. So if you see different genders, you know that it must have come from two separate fertilizations. That means it is dizygotic. And if it's dizygotic, there's no way to share the amnion or the chorion, so it is also dichorionic and diamniotic. This constitutes also the baseline risk of having multiple gestations. The risk is going to be preterm labor. And the general ballpark is going to be for every one gestation, you'll deliver 4 weeks early. And because there's 2 babies in there that are competing for space, you're likely to have malpresentation. Some sort of breech birth of at least one. And that breech birth then ends up having an increased risk of C-section. Just a caveat, it is okay to deliver baby number 1 if the head is engaged and the orientation is appropriate, and then do a C-section for baby number 2. Or you could just do a C-section for both. And because there are multiple placentas trying to get mom's blood, you should have increased risk for postpartum hemorrhage. But if the genders are the same, now you've got the potential for a single zygote which has split to share the genetic material. You could have 2 separate fertilizations that share the same gender, but for this discussion, let's just assume that they're going to be the same gender because they come from the same zygote. You won't be able to tell that the same gender has come from 2 different fertilizations if they are the same gender until they come out of mom. So after looking at the gender, if they're the same, the next thing you want to do is look at the number of placentas. Because if there are two placentas, then you have a monozygotic, one fertilization, dichorionic, multiple placentas, diamniotic, two sacs. The only risk, it's not really risk, but the only risk that this carries over the usual twinning is going to be that it's possible they are identical. You won't know that it is identical until babies come out. Because they share the same gender, but they have two placentas, it could look very much like fraternal twinning, the dizygotic, and you won't know until they come out. But if you see one placenta, now you know for sure that it's a monozygotic pregnancy. And at this point, you're going to use that same ultrasound to look for the septum and the number of sacs. If you have a septum and two sacs, then you have a monozygotic, came from one egg, monochorionic, they share the same placenta, but diamniotic, twinning. They share the same placenta, but have completely different sacs. Because they share the same placenta, they share the same blood supply, they're at risk for twin-twin transfusions. If one baby gets higher than the other, gravity will have blood flow into the other. And when they come out, the baby who got the transfusion will look big and strong, but will do poorer because of the excess bilirubin load. The baby that did the transfusing will come out scrawny and straggly, but do better. And lastly, if you see no septum and only one sac in a set of twins, you have merged amnion, so you're going to have a monozygotic, monochorionic, monoamniotic. In this case, you've got two additional risks. You are going to have risk for conjoined twins and cord entanglement. Conjoined twins can be surgically removed as long as they do not share two major organs, and cord entanglement can lead to problems with the delivery, which is one reason why we go to C-section. And the way I want you to see this is you start here at fraternal twins, the dizygotic, and go clockwise around. So that monozygotic is number 2, monochorionic is 3, monozygotic, monochorionic, monoamniotic is 4, and the risk stays with you as you increase. All pregnancies at risk for preterm malpresentation, C-section, then you add on identical twinning, then you add on twin-twin transfusion, then you add on conjoined twins and cord entanglement. Let's go through this one at a time with drawings to help you understand what's going on. Let's start with dizygotic, and I'm going to abbreviate for the sake of brevity. The dizygotic, dichorionic, diamniotic. Twinning. This comes from 2 fertilizations. Therefore, there must be 2 placentas and 2 sacs. You often have 2 genders, and you most certainly will on the exam if they're going to ask you this question. What this looks like, this is mom's uterus. There's going to be 2 separate pregnancies that happen to share the same uterus. So there'll be 2 placentas, there's going to be 2 sacs, and there's going to be 2 organisms developing inside. The risk is the same as all twinning pregnancies, preterm labor, C-section, malpresentation. In the monozy, dichorionic, diamnionic. The pathology is that you have a single fertilization that split very early. The earlier the split, the more separate the fetus is. A split between days 0 and 3, the tubal phase, when the embryo is still traveling and hasn't implanted into the uterus yet, you will end up with 2 organisms and they'll have 2 separate placentas and 2 separate sacs. This looks very familiar to what we just drew. That is, there are 2 separate pregnancies that happen to share the same space. They are 2 placentas, 2 sacs, and 2 organisms growing within. It's just in this case, if they're the same gender, and it is truly a monozygotic, they have the same genetic material, so are identical. In the case of a monozygotic, monochorionic, diamniotic pregnancy, you're going to have 1 fertilization that's split a little bit later. That is between day 4 and 8, the blastocyst phase. Because they split a little bit later, they're going to share the thing that's furthest on the outside. They're going to share the chorion. So there will be 1 placenta for monochorion, but still 2 sacs, diamniotic. The way this looks is going to be that 2 separate developing fetuses share a common placenta. The developing sacs are separate from each other, and they have developing fetus within each one. But the blood supply is connected between them, and so this allows for twin-twin transfusion. Remember, the smaller twin does better. If you've got monozygotic, monochorionic, and monoamniotic, this split happened much later. You still have 1 fertilization, you still have 1 placenta, now you'll have 1 sac because they're developing within the same sac, and if the split occurred between days 9 and 12, you're going to have non-conjoined twins. If it occurred after day 12, you'll end up with conjoined twins. This is going to require 2 pictures so we can see what's really going on. In the non-conjoined form, there's going to be a common placenta, just as we drew above, and there's going to be a common sac, with the embryos growing inside the sac, surrounded by a common amniotic fluid. In the conjoined form, it looks very similar, except that the 2 developing fetuses are literally connected to each other. They still share a common placenta, they still share a common sac, and now they share a common embryo. These gestations are at risk for cord entanglement as well as conjoining. So what I really want you to hone in on is this. Using the words zygotic, chorionic, and amniotic the right way. Zygotic means the number of fertilizations, the number of zygotes. Chorionic means the number of placentas, and amniotic means the number of sacs. And also know that you have increased risks as you escalate. And then a little bit of embryology, recognize that monozygotic dichorionic is a tubal phase, monozygotic monochorionic is the blastocyst phase, and twinning must occur the latest possible after day 12. That is multiple gestations.